First, let's talk about flop subset selection. If we choose a large number of flops, we get a result that will quite accurately model a game, but like I touched on earlier, the larger the subset, the longer it takes to run the multi-flop aggregation reports. Just a rough idea, if you're using a 49 flop subset and you're doing 10 scenarios in the whole study, 6 for single raise pot and 4 for 3-bet pot, let's say, you're going to be able to do 3 to 4 scenarios a day, with each one taking around 2.5 hours. So that's 2 to 3 days to do them all. While they're running, obviously you can be doing your other things like configuring your mass database, extracting and entering your data. But if you run 150 flops instead, each one's going to take around 7 hours, so now you can only really do 2 a day, and the project is taking you 5 days instead of 2 to 3, and this part of the process is going to become the bottleneck in the whole study. In addition to the runtime of the MFA, the larger subset's going to take up more space on your hard drive, obviously 3 times as much, as you'll want to run solves overnight and be working on them in parallel. Solving with very large flop subsets, you're likely going to run into storage space issues. The solves themselves are also going to take longer, and even though you can run them overnight, you'll still run into a bottleneck with very large flop subsets. So clearly we're incentivized to investigate whether or not we can use the smallest flop subset. Here's the scenario of big blind versus small blind single raise pot with our opponent as the imposition pre-flop caller. The table shows results from the 49 flop subset that I showed you earlier, and a larger 153 flop subset. Here it is. Just for reference, you might recognize it if you've used it before. We can see from the table that there's very little data in the data produced by the two subsets. There is a gap of 0.8% in the flop stab and a gap of 0.6% in the fold versus check raise. But for everything else, the gap is sort of 0.3 or less. Of the two, we have to assume that the 153 flop data is the most accurate, the one that most accurately models the game. But the question is the 49 flop data close enough, given the considerable practical benefits that it offers? So the question is, how relevant are these deviations? We can judge this relevance by putting the data into context alongside the pool's data taken from our mass database work. So the data in the blue rows is the pool data from the mass database work that I've done. This has come from my hand-to-note software, and it's using 120 million data point hands taken from a 20 million hand database. I'll explain the concept of data point hands in the database section of the pack. It's not really relevant yet, and other than to say that the sample sizes in each cell are very large, as you can see from the numbers in brackets. Just going back to the PO data, this was all taken from the parameters that I showed you earlier. So out of position 43% open, big blind defend 37% because that's what I had from my environment. These are the sizing parameters I put in, and I've changed them where appropriate by adding and removing lines like I showed you. So let's focus on the gap then between the pool data, the blue rows, and the PO data in the orange rows. So for the flop stab number, where we saw there was a 0.8% deviation in the 153 flop subset result and the 49 flop subset result, the gap between what the pool's doing is 8%. So I would argue that the deviation of 0.8% is insignificant when it comes to the gap between what the pool's doing. So the hotspot is so large that the deviation in the extra accuracy we gain from using the 153 flop subset in this case is negligible and probably not worth all the extra inconvenience that I've outlined. This isn't really a hotspot though, like how often the pool bets when we check to him. This is a hotspot, the fold versus delayed c-bet, so our opponent checks back the flop when we bet the turn. So when I put in the pool data, you can see the hotspot is huge, 18%, so any deviation between the PO 49 flop subset and the 153 flop subset is very negligible compared to such a huge hotspot. And you see that throughout down here where there was a 0.6% deviation in the two flop subsets, there's a hotspot of 8-9%. So it makes this error insignificant. So I'd say from this we can conclude that the 49 flop subset seems a more sensible option to be using in this study. Just to emphasize it though, I'll show you the same scenario with roles reversed. So this is a different grid. This is small blind versus big blind, where our player is out of position as the pre-flop raiser. So we're looking at his flop c-bet number. If we focus on the orange rows first to gauge the error between the 49 flop subset and the 153 flop subset, we've got 0.7% difference here on the c-bet. But when we put that into context with the overall sort of gap between the PO data and the pool data, the gap is huge, 18%. So an error of 0.7% is insignificant in that context, especially when we consider all the extra work and effort we have to go through to get that extra bit of information. Flop c-bet isn't really a hotspot. It's not something we can exploit directly. If we look at a hotspot such as the check fold number on the flop for the pool, a very negligible difference in what the two different subsets offer as PO's answer for the scenario. But the hotspot is huge, 20%. So again, it seems like taking the larger flop subset is not the best approach. If we wanted to extend this discussion on and go to the extremes, we could ask, is 153 flops even enough? Should we be using like 1,000 flop plus subsets? But I think it's clear just from looking at these numbers intelligently that any extra accuracy gained by going past 153 flops is not going to confer any significant advantage in the data when we put it into context with the type of hotspots that we're going to be unearthing in this work. So because of what we found there, the rest of the data, the hotspot information that I present to you in the pack will be from the 49 flop subset. So moving on now to look at the effect of rake on the results. So this is from a 49 flop subset, big blind versus small blind, single raise pot, the pool in the big blind. 120 million data pi hands for the mass database analysis, just the same mass database data. All the other parameters are the same as the previous, ranges, bet sizings, and so each of the orange rows represent the PO data for a different set of rake conditions. So at the top we got a no rake, obviously 0%. Then we got the rake at 400 NL stars, which is 5%, with a 7.5 chip cap in terms of our model, if you remember, where we were using 1,000 chip starting stacks. Then the third row down, I've got the rake merged between 100 NL zoom and 200 NL zoom, because that's the large database that I've got. And at the bottom, I've got sort of like a worst case scenario for rake, 5% with a 60 chip cap at 50 NL, which represents 50 NL at iPoker. So the reason I'm presenting you this information is sort of to try and answer two questions. The first is the rake relevant in this context? Is it worth including the rake? And the answer to that is pretty straightforward, given that it's so easy to include the rake in our solves. As I showed you here, we can just tick this box. There's no extra inconvenience or effort required. We just input the rake definition, save it in our parameters, and use that in all of our solves for all of our studies. So, I'd say that even though the deviations here we can see straight away don't look great, it's definitely worth including rake, and it makes sense to match the sites we're playing at. The second question is it worth sort of stressing about exactly which rake structure we choose. In other words, if we start out studying 50 NL high poker and then we decide to move to 100 or 200 stars and then in the future up to 400 on stars, do we need to bother resolving all of our MFA work in order to account for the change in rake that we're experiencing? So we can judge that by comparing the differences in the rakes and then putting it into context against the pool's data. In terms of the differences in the results from each of the different rake conditions, the most relevant place to look is the hotspots. So if we look at the fold to delayed c-bet hotspot for imposition, where he checks back the flop and we bet as the out of position player. If we look at the no rake situation first, there's like a jump of 2% between the no rake condition and the condition with the most rake. But in the context of the hotspot, where the hotspot is like 20%, I mean that's irrelevant. That 2% jump from no rake to high rake. And if we look at what we'd actually be the band we'd actually be jumping within, if we went all the way up from 50 NL up to 400 stars, you know, the deviation now is only 0.5%. So in that case, it's certainly not going to be worth redoing all your MFA data as you move up stakes. Let's take another hotspot, the fold to check raise, so the bet fold stat. Here the gap is a bit more significant. Between the high rate condition is 41.6%. The lowest of the three rakes that I've got is at 400 NL stars, the number's 39.9%, and with no rake at all it's 37.5%. So we've got a 1.5% gap there between 50 NL high poker and 400 NL stars. But again, the hotspot is 9% at 400 NL stars, or it's 7.5% at 50 NL high poker. So, you know, just as like a gut intuitive feel, you can see that in the context of the hotspots we're going to be finding in this study, it's not worth redoing your MFA data as you change stakes. So for that reason, I'll be starting out with my rake structure set to map 100, 200 merged rake at stars, where, as I explained earlier, I took the average rake across the 200 NL and 100 NL, and I'll apply that to all my solves when I go and plug in different environments, and I think this shows that that's a reasonable thing to do. So let's move on to talk about the effect of the sizing structure that we've set in our parameters. So I spoke earlier about how to set the different sizings by street and how to change them to split whether or not it's a barrel, so a continuing aggression over from a previous street, or whether there was no aggression on a previous street. So you can do that by adding and removing lines. So I've entered that data in here, and it's probably easier if I illustrate. Like in this line now, I want where the out of position player didn't aggress on the previous street. If in position checks back, I want out of position to be bet in half pot. So you can see that's half pot there, 30 into 60. And similarly, if out of position checks, in position is going to bet half pot. Whereas if I show you another example where I haven't distinguished between a barrel and, let's call it a stab or a delayed c-bet. So here I've deleted the information about whether or not to add or remove extra lines. So all the turn and river bets now are going to be 66% regardless of whether there was aggression on a previous street. And I've built you the tree to show you, so now when the flop is checked through, out of position is leading 40 rather than 60. And when checked to, in position is betting 40 rather than 60. So that difference of sort of, you know, jumping up from 50 to 66% is clearly going to impose a change in how PO responds. But let's have a look at how great that change is. So all the other parameters are the same, like with the previous grids I've shown you. So the top row here in orange is where all turn and river bets are 66%, and the row below it is where the stabs and delayed C bets, so where there was no aggression on the previous street, is reduced from 66 to 50%. So if we focus on the hotspots, the first being in positions fold to a delayed C bet. Now there is a significant difference here in PO's response to whether or not our turn lead as the out of position player was 50% here. PO is going to be folding 37.1%, and if we bet a bit more at 66%, he's going to be folding 7% more often. So I'd say, that's the most significant deviation we've seen so far. But still, in terms of the context of the size of the hotspot, it's still a huge hotspot, like 11%. So however we run our solve, we're still going to be finding a big hotspot, and the practical application of that is for us to aggress into that hotspot very frequently, whether we find it's 11% or whether we find it's sort of 18%. If we look at another hotspot then, the fold to the check raise, the numbers have converged considerably there. The hotspot is 8% regardless of what size and structure we used. If we go forward to the river, check, check, fold, we're seeing 66% bet on the river in the top row at 48.2, and in the bottom row at 42.3, we're seeing a 50% river lead. So obviously we're going to have a gap. But when you look at the size of the hotspot, I mean, it's huge, whichever number we happen to have used in our models. Same here on the bet check fold. We've got a 4% gap between our two numbers, but both result in a significant hotspot.
We saw earlier that from the hand to note tool, we can make a fairly good estimate of what the pool's likely bet size in each scenario is on average, and I kind of estimated it was likely to be 60% for the stabs, although there was some guesswork still in doing that. It's probably closer to 60% than it is to 50% on average from what we saw. But I think this shows that if the pool on average is making a 60% sizing, what's PO's response going to be? Looking at this on a sliding scale, probably somewhere around the 41% mark. Hotspot is still significant, 14%, and it's going to be the same as we've already discussed in all the other hotspot cases in this grid. But there's another reason that I feel this information is quite useful, and that is not just to determine sort of the ideal parameters to use in this study, which is kind of how we've been approaching it so far, but if we take things on a step further, once we've identified there's a hotspot, which there clearly is here, let's say in the check back fold turn line for imposition, in practice, if we want to exploit that hotspot even further and put the pool under more pressure, the sensible thing to do would be to make a smaller bet size than the pool faces on average in order to force them to call even more often when we already know that they're not calling enough. So if you like, if the true sort of pool versus pool hotspot is sort of 41% versus 55, PO would fold 41%, pool folds 55%. If we bet 50% instead of what we think the pool's average is of 60%, we force the pool to adjust at least as well as PO does in order just to maintain a hotspot of 14%. And the same logic holds for all the other hotspots. Check, check, fold, betting the smaller sizing on the river bet puts even more pressure on the hotspot. Same for bet, check, fold. Now let's move on and talk about the effect of pre-flop ranges. So I explained earlier for the scenario of small blind versus big blind single raise pot why I chose the ranges of 43% and 37% is because that's what the average pool data was showing me from the mass database analysis that the pool was playing in each of those spots. 43% in the small blind, 37% defend in the big blind. But what if we choose to open significantly wider than that? What if we're in the small blind and we choose to open more like 70% in order to exploit this fairly low defend percentage by the big blind that we're seeing? What if we transition from this 43% open all the way up to something like this, a 70% open? What effect will that have on the hotspots that we find in the study? So here's a comparison of what PO would do when he's in the big blind versus the small blind, the single raise pot in position pre-flop call, playing against a 70% small blind opening range, the top orange row, and a 43% small blind opening range in the bottom orange row. 43% is what we've used so far. So we're talking about using an exploitatively wide small blind opening range now. So in terms of the flop stab, obviously that goes up for imposition because he's playing against a weaker range. But like I've said before, this isn't really a hotspot for us anyway. The hotspot is down here. The first hotspot is down here at fold to delayed c-bet. So what's happened here? The hotspot's actually got bigger. There's like more pressure on imposition now to fold less. And given that this is an area that we already know that the pool is making a mistake in from when we modeled what the pool does against the pool on average, which is looking at the 43% small blind opening line, we saw there was an 18% hotspot. If we open wider in order to exploit the fact that big blind doesn't seem to be defending enough pre-flop, we not only get that value from that pre-flop exploit, but we land in a position post-flop where we've already identified a hotspot, and we push in position into a more uncomfortable territory. We challenge him further to play well in an area in which we already know he's playing badly. So this just seems like a win-win scenario. Like, even if the in-position player knew that we were opening so wide, the first sort of assumption of the community might be to sort of deduce that, well, in-position is going to play a lot better. But if we just forget about the 70% line for a minute, the 43% line shows what the pool is doing on average against the pool in position, and that's the way the pool's been playing against the pool for years. And there's an 18% hotspot there. So it's a pretty big assumption to assume that against one player who, if he has managed to identify, is raising significantly wider than the average player by opening to 70%, he's then all of a sudden going to be able to play and adapt better than Solver would and bring his defense number down anything significantly from 55%. Like, realistically, is he going to be able to adapt by adjusting his fold frequency by 5% like Solver does? And even if he did and brought it down from 55%, there's still an 18% hotspot remaining. So this just seems like a win-win to be opening wider in the small blind, in that, like I said, we're exploiting pre-flop, we're getting it therefore into the post-flop hotspot more often, and we're widening that post-flop hotspot by putting the in-position player under more pressure. But the other reason to show this is, like, to deal with the question of, well, what if our pre-flop ranges are changing very marginally
between environments? Do we need to go and redo all our multi-flop aggregation reports? And like we've seen with a large variation in range, there is a somewhat significant change of 5%. But if you're talking about moving from an environment in which the small blind opens 43% to an environment in which the small blind opens 45%, just looking at these numbers, it's clearly not worth redoing your multi-flop aggregation reports. If the small blind opens 10% more and the big blind plays a different range get as well by 10% and things change dramatically, then maybe it's worth doing it. But like we've seen quite a big change here, and whilst the PO result is changing a bit, it's not massively significant. That being said, like I said, if you are moving to an environment in which there's a 10% change in ranges or something like that, you may feel more comfortable about redoing your multi-flop aggregation reports. But in terms of whether it's worth stressing about it, if you've got like a 2% difference, so there's basically no point worrying about how you exactly map your pre-flop composition, whether it's 43 or 43.5% or the exact makeup of the smattering or the exact margins of where you're folding and calling. It's not going to make a huge difference, and we can see that from these numbers, I think. So now I'll show you the same thing, roles reversed. So now the player, the environment we're mapping is in the small blind, out of position, single raise pot as a pre-flop raiser. The bottom of the two orange rows is where the big blind that defends 37%. This is how PO would respond as the small blind. He'd c-bet the flop 38.1% against a 37% big blind pre-flop calling range. But what if, as an exploit to the post-flop hotspots we've seen, we want to defend a lot wider than that? If we defend 64%, then PO as a small blind is going to c-bet 53.7% into us. So a significant change there in how PO responds. But the flop c-bet isn't a hotspot that we're interested in. The hotspot is down here at the check fold. And you can see that with the two different ranges for the big blind defense, the PO response is more or less the same, and the hotspot is of the order of 20%. So this suggests that we can, by calling with a wider preflop range, a much wider preflop range than the pool, just arrive in the spot a lot more often post-flop and take advantage of the 20% hotspot a lot more often. I think it's something worth noting here that when we look at the big variation that PO implements in his flop c-bet number against the two big blind ranges, there's a big variation there, but then in all the subsequent actions, the variation is very negligible. So it's like PO has already sorted out the difference in the ranges with his first flop action when he's in the small blind. And then from there, everything proceeds as if it's the same. So all the hotspots that we took, we've already spoke about the check fold hotspot, but the check fold on the turn after betting is 10%. Check fold on the river after betting flop and turn is 10%. So all the hotspots are intact, even if we play a much wider pre-flop call-in range in the big blind. And this pattern of like everything coming together after the one decision point in which PO varies things is a pattern that we'll see again and again. So like the secondary finding of this, in addition to the finding that playing a wider pre-flop call-in range seems to be okay in the context of this study, is that even if we have a wide variation in pre-flop ranges, there are only going to be a couple of decision points in which PO's result or the way PO would play is going to vary significantly. Most of the other decision points in the scenario, PO is going to do things quite similarly because he's already sorted out his range in that initial decision point. In this case, the flop c-bet.
Now let's talk about board texture variations. So here I've got a grid for small blind versus big blind single raise pot. Small blind being our opponent. So we're interested in how often he's c-betting. Here I've got the pool information as normal in the blue row. Here I got the PO in the 49 for the 49 flop. The PO data in the orange row there. And in these two orange rows above, I've got some MFA data for a small subset of ace-high flops. I created these by running a solve on a 153 flop subset that I used for some of the previous data I showed you, and from there I extracted all the ace-high flops in the folder. I copied and pasted those into a new folder along with the original solving script so that I retained the weightings, and then ran an MFA on that folder of about 15-20 flops. And I did the same for the 9 high and lower boards. So this isn't a completely accurate way of doing things. It's a small subset, but it is a subset of ace-high flops and a subset of 9 high flops, and we're just trying to determine how, the PO-MFA numbers would vary to some extent, even though we know we can't be completely accurate about it. Below in the grid, I've got the textural data for the pool's responses for ace-high rainbow boards, king-high rainbow boards, less than 9-high rainbow boards, and then the same for two-tone boards. In the Holder Manager tutorial, I'll show you how to quite easily capture this information in your reports. In Hand to Note, I'll show you how to go into more detail and produce your own reports that will look something like this. So here I've got all the flop texture information that I had in the previous grid, and then I've got some variations like rainbow boards grouped together, two-tone boards grouped together, information for different types of turns and rivers. So here, for example, this is the double barrel column. This is for the flop being queen-high rainbow. There's no stipulation regarding the turn card in there. Could be an ace, could be a king, could be a 5, whatever. I won't go into too much detail on this at the moment. Just wanted to show you what you'll be able to get later in the pack, and explain to you how I got the information in this grid. The bottom section of texture data I've kept off to make it sort of presentable on the screen for you, and it's not really relevant to the discussion we're going to have anyway. So there's two kind of reasons to have this discussion at this point. The first being, how useful is the textual information that we can get from the mass database analysis? In the methodology we've used so far, we've taken the average pool response in each decision point and compared it to the average PO number, the average across different board textures. Now that we're able to get board texture specific pool information, can we still relate that to the PO average board texture number that we're able to get? So what I hope to do here is, by going into and doing another set of solves on some specific board textures as sort of samples, I hope to be able to show that we can use the PO average board texture response to determine some interesting findings about how we can adjust our strategy on different boards without having to go in each case and do a board texture specific MFA, which is quite a bit of work. I've explained to you the methodology I use to do it. You can go off and do it if you wish. And the sort of second related reason is just like, well, okay, we're using this methodology of comparing the average pool information against the average PO response, but what happens on specific types of boards? Does the pool play fantastically well on a certain type of board and atrociously on another? therefore should we be avoiding some types of boards and going in harder on others? So let's look at the flop C bet first then, even though this isn't a hotspot as such. So the pool is C betting on average 53% and PO is C betting 38%. When we split it up by board texture, PO would bet a little less on the ace-high boards, and the pool, if we compare this 51% number on ace-high rainbow with this 56% on 9-high and less rainbow, the pool also c-bets a little less on the ace-high rainbow than it does on the less than 9-high rainbow. But it's still like way above what PO would do on ace-high rainbow and less than 9-high rainbow. So like if we just look at the proportions, the hotspot that we identified when we looked at the 53% number and compared it with a 38% number is still intact if we were talking specifically about an ace-high board or a 9-high board. Both numbers have moved up by the same sort of 5% approximately. Then moving down to where our hotspot is on the check fold. So we identified by comparing this 36% with this 55%, like roughly a 20% hotspot. PO would check fold both boards roughly with the same frequency, like a 1% difference. And when we look at what the pool does, we've got like a 3% difference. So, roughly the same. So again, like hotspot still intact on both boards. Let's move ahead to where we see some differences. So hotspot here, comparing the 57% with the 48%, 10% hotspot. When we look in then at the difference that PO would do on ace-high rainbow and less than 9-high rainbow, is a 10% difference. So, okay, in the context of a 10% hotspot, we need to look in a bit closer at that. So let's look at what the pool does. This is the check fold after betting the flop on the turn, check fold on the turn. The check fold the turn 64% after an ace-high rainbow flop, and 54% on the 9-high and less rainbow boards. So that 10% hotspot that we identified by looking at the average data is still intact for both the ace-high rainbow board, 64% versus 55%, and the 9-high and less board, 54% versus 45%, 44.5%. So from this we can see that the pool is deviating with roughly the same sort of order of magnitude as PO would, but it was out in the first place. The pool was out in the first place, and it's sort of still out to the same degree on both board textures. So we have to assume that all the sort of board texture types in between ace-high rainbow and 9-high rainbow are going to follow the same pattern. We don't really have to, from this, go off and do it for king-high rainbow, queen-high rainbow. And I think, more importantly, we can just extend this sort of inference and say, well, in future, we can rely on the gap between what is the average pool information here, 57%, and the average PO number, 48.5%, and say that hotspot is likely to remain intact on all the different board textures. Let's do another one. The check fold line on the river after double barreling. So if we call this 56% for what the PO does across the 49 flops, there's an 8% hotspot in play there. Let's look at what PO would do on an ace-high rainbow board, 61%. It would be folding. The pool folds 69%. So again, the 8% hotspot is intact. For 9-high and lower, PO would fold a bit less, 54%, pool 67%. So it's at least intact. It's actually a bit bigger there. So I feel like this analysis, it's like in the scope of the videos I'm producing for the pack, it'd be unwatchable for me to go through and prove all these different board textures to you for every discussion that we have about board texture and board texture related hotspots. What I've tried to do here is take the two extremes, ace high and 9 high, and show that the hotspot that was present across the average data remains present when we look at the board texture specific correlation. And I think we can apply that to different scenarios. If you feel uncomfortable about applying board texture information, then I've explained to you a methodology in which you can go and extract an estimate of what PO would do across board textures. You could always go and do a much bigger solve than 153 flops and go and extract all the ace high flops from that, from example, and then arrive yourself with a 50 or more ace high flop subset. I'm very confident that it's going to return you the same sort of findings. And then down here, where there are more minor hotspots in these lines, I'm not giving the board texture information, like I said, just to make the presentation cleaner for you. And also, there's no variation anyway between what PO would do on the ace high rainbow and 9 high rainbow boards when we look at these numbers. If you are skeptical and you don't like the sort of logic that I've applied there, and you don't want to use board texture information, then you can just skip those sections later in the pack. The majority of the pack is focused on the main hotspots discussions that we've had so far. I just do offer you the alternative and to be able to go off and get texture information if you wish. If you like the idea and you are comfortable in making sort of a slight sort of leap of faith in these areas, then you'll be able to go off and dig into more detail in terms of board texture variations, especially with the methodology that I'll explain to you in the hand-to-note tutorial. So now let's move on from the conversation about board texture variation and talk about variations in range composition and their effects on later street hotspots. So earlier I showed you the effect of us playing a wide small blind open range of 70%. So a significant deviation from what the pool is doing, where they open 43% in the environment I've been studying so far. So here now we're looking at things from the point of view of the big blind versus the small blind. So we're looking at the flop stab again. And I'm presenting you the data, some of the data that I showed you earlier for us opening with a small blind range of 70%. This is the PO data for that in these rows. And in the row below, I show the PO responses that imposition would take versus a small blind open of 70% that's checking range on the flop, so no flop c-bet allowed for out of position. So I'm showing this to try and address the question of well, okay, if we're playing a check range strategy, then are the hotspots that we've identified still relevant? So if we look at the flop stab first, when the small blind is allowed to c-bet at the optimal percentage, the in-position player stabs 45% of the time, and when the out-of-position player is not allowed to c-bet, the in-position player stabs quite a bit less, 14% less, because the out-of-position range is that bit stronger. But as I've said before, the flop stab's not really the hotspot we're interested in. The hotspots are down here, the fold to delayed c-bet, and the numbers are identical, or near as identical in all the hotspot lines. So I think this confirms that we're not losing anything if we choose to play the check range strategy, as out of position. All the hotspots we identified by using the optimal c-bet frequency for out of position are still in place to the same extent. It's interesting that we're seeing the same effect here. We're seeing a deviation at the first decision point, and then everything converging after that. We saw that in one of the earlier comparisons we did. So what we've actually studied here is the effect of c-bet frequency for out of position, isn't it? We've taken the c-bet frequency down from whatever optimal it was on each board texture down to 0 on all board textures. Let's move on now and talk about actual range composition and the effects that variations in range composition can have on later street actions and therefore on our hotspots. Let's switch positions on the blind versus blind scenario again now. So let's say we're in the big blind and we decide to play a wide-ish pre-flop calling strategy, something like this, in order to exploit the post-flop hotspots we've identified from the small blind. Playing in a range, presumably something like this, around 43%. This is the range consistent with the studies I've shown you so far. I've shown you these ranges for this scenario before. I just want to repeat them again for completeness before this discussion of range composition. Here's the parameters I've used in the solve. So the ones I've shown you so far with 50% on flop, 66 turn and river, but if the bet on the turn and river is like a stab or a delayed c-bet rather than a barrel being continuing aggression over from the previous street. So if it's a stab or delayed c-bet, I've dropped the sizing down to 50% instead of 60% with these amendments. So what I've done is from the folder that was generated from this solve of 49 flops, I've pulled out an example board texture, Queen 4 Deuce Rainbow, and this is the PO suggested optimal c-bet frequency and c-bet range composition. Now so far in the methodology, when we've identified hotspots, we've done so under the assumption, for obvious practical reasons, that the small blind in this scenario, or the pool, whatever the different scenario may be, is betting optimally. We know obviously that that's not the case. We don't really know the degree to which the human in the small blind is not betting optimally, but we could make some assumptions. And so by making some assumptions on a deviation of range composition, we could check the effect that has on the hotspots we've identified. It's clearly impractical to do this in every scenario for every board texture, but by doing it in one case, I hope to use that as like a test to prove or disprove the validity of the methodology in general moving forward. So before we make any deviations in the range composition, let's look at the allowable check fold on the flop from optimal on this board. So this is the check fold decision point for the small blind, having played the flop with an optimal c-bet or check strategy. We can see small blind's allowed to fold 30% of the time. So we'll use this as kind of our reference point. It's important to note at this point that regarding the board texture I've chosen, I chose this type of board because I wanted something that is quite easy to define. The groupings of hands on the flop is going to make the range composition discussion a bit easier for us to agree on. The slight drawback is that we could probably say that this is like a high c-bet frequency board for small blind. Small blind's betting 62%, and on average PO wants to bet 38% of the time in this scenario. We can see that, as we've spoken about earlier, the pool on average across average board textures is betting more than PO would, 53% versus 38, and that correlation held true when we broke it down to look at ace high and 9 high rainbow flops. 38 versus 51, 43 versus 56. So it's probably safe to assume that even though the Queen 4 deuce is like a high c-bet frequency board for small blind, it's probably safe to assume that the human in the small blind is going to c-bet with a higher frequency than that. So let's look at the effect of bumping up the c-bet frequency a bit. Here I've taken it up to 67%, basically by adding in a higher frequency of overpairs and good queens, the low sets, 2-pair, and the ace-high gut shots. So what happens to the check-fold range on the flop after c-betting with this range? We can see that it's gone down from 30% to 26%, so the small blind has to defend more often if he c-bets that slightly higher c-bet range and slightly value-heavy c-bet range. So as a first step, this looks quite good for the sort of attacking the hotspot methodology, because on the evidence we've got, going back to this grid, it seems like the small blind is going to bet more often than PO, if anything, if it's going to deviate in any way. And we've seen that by making a change there, a slightly value-heavy change as well, which I think is a reasonable assumption to make. The small blind is required to defend more often. This is quite a simple first step, and I'll offer two options. One being like a polarized deviation from what PO would do. So, and the other would be like a more merged deviation, and we'll see the effects that they have. The best way for us to do this is to go back to our optimal c-betting range and use this as a launch pad, because we don't want to be deviating both frequency and composition. We want to be keeping all the variables constant and just changing one. So we just want to explore composition for now. So let's go into PO and show you how we can make these deviations. So here's the optimal c-bet strategy. If we go into tree, set strategy and lock node, bring up the betting strategy. So first we want to make this range like more polarized. Previously I just did a simple modification just to see an initial effect. I added in more ace queen, king queen, everything above queen 10. I added in the ace high gut shots and the overpairs. So we can do that just by changing those frequencies to 1. And let's allow him to check the top set and bet all of the bottom sets and 2 pairs. I suppose in order to make it polarized we should put in the top set there. So just to try and keep it simple, let's put in all the queen X and better, and let's take these pairs up to 1. And let's take these pairs down to 0. And take ace jack down to 0. I suppose these can be classed as a value bet. It's going to get called by weaker unpaired hands. We're trying to polarize him. Take the ace king out. On end we'll add in some hands down the bottom end, like the weaker bluffs. So take these up. So I think that'll do. Let's take a look at the effect it's had on the frequency. So click OK. Take that to fixed. So the frequency stayed roughly the same. And we've somewhat polarized the range there. So now hit lock all hands, set strategy and close. And that grid gets input. You can see ace, king, ace, jack have gone out, jacks through nines have gone out, sevens and sixes have gone up. All the queens are in and better hands for value, and we got some bluffs in there taken up to 100%. You know, this is all an approximation. I'm just trying to give you some example deviations from optimal. So we can see that the range has been locked, and now if we go back and hit go, it'll resolve for us. I'll come back when it's finished. So the solve has stopped. It's reached the required accuracy that is specified. Let's go in and take a look at the results. The allowable fold percentage is down even further now. This is what it was at optimal. This was from the optimal c-bet. And when I attempted to make a polarized deviation from the optimal c-bet, this is what we got. I suppose you could argue, did I polarize that range enough? Like, did I not put enough bluffs in the betting range? So I'll go back in to the betting range and make some modifications. So now I've taken out the middling pocket pairs and ace 10, ace 9, and I've added in all the air in this region and this region, and I'm at a sort of consistent c-bet frequency. That's locked. Let's solve that. If it is that the pool constructs its range, its c-betting range, in a way that's as polarized as the one we just locked for, then it's required to fold at 21%. But we know from the data that they're folding 55% on average and 57% on the average queen high rainbow board. So the hotspot is just widening from the range compositions deviations that we've seen so far. Let's take a look before we let go of this polarized range. What happens if in the bet check fold line, so the check fold on the turn after bet in the flop. So let's pick a turn card that's pattern wise sits similarly alongside a lot of other turn cards. That's one advantage of choosing a flop like this. So facing the stab on the turn, out of position, is allowed to fold 43% of the time. We see from the data that they're folding 57% of the time. So hotspot's still in play there. Again, we're drilling down into specifics. I'm just looking at one specific board and one specific range, but I'm just trying to highlight the sort of deviations that occur and that they're not invalidating any of the hotspots that we found. In this particular analysis, there's a lot more moving parts, like what is the in-position flatting range, what is the out-of-position barreling range on the turn, but it's clearly infeasible for me to cover all the moving parts. Just trying to stimulate a discussion with some examples. So let's leave the polarized flop c-betting range and take a look at the effects of a more merged c-betting range. So to do this, let's go back to the optimal c-betting range and branch off from there. And let's basically do the opposite to what we just did when we attempted to make it polarized. So here I've got out of position, checking the overpairs, checking all the decent queens, just betting some of the weaker ones, betting all the pocket pairs, checking his sets, checking his two pair, and then betting the good aces. So obviously this is an extreme case of a merged range, but the only way to test something really is in the extremes. I've also removed all the bluffs. This is what we get. The c-bet is dropped down a bit. So the solve is completed. So now the flop fold is up a bit in percentage terms, 36%. If we compare it to the optimal again, which was 30%, and if I just try and put the grids side by side, you can see there's like more blue in the sort of the complete air regions, and also in the merged range, like there's none of the strong ace-x for the small blind to call because he bet them all. This is the optimal. Also, he bet all the medium pairs in the merged range, but on the other hand, he checked all his strong hands, so they're there to be called or raised. So you can see that the raise percentage is up at the merged range. So if the pool playing a range typically merged like this, okay, they're able to fold a bit more. But in terms of the hotspots we've seen, which was 55% on the check fold, 57 for queen high boards, like they're still nowhere near. Just intuitively, if we were to try and come up with a c-bet in range that allowed the pool to get anywhere near fold-in 55%, it's probably going to look something like it would if we'd have bet like a lot more of these queen x and ace x. So let's go back and input a range that looks a bit like that. So here I've got all the ace x being bet, queen 10 and bet are being bet, aces and kings, two pair and the two low sets. C-bet percentage is back up to around 65%. So this is let's call it a merged value heavy range. So very light on bluffs. So now the allowable fold is up to something in the region of what the pool is actually doing. 57% on Queen Eye Rainbow, 58%. But a couple of things stand out. I mean, we arrived with a pretty extreme range here, and a pretty extremely weak check-in range. There's a few bits for Queen X, tons of A. And also, PO's raising hands like Queen 7, Queen 8, Queen 9 with a very high frequency, which we can be confident that the pool just aren't doing. And if he's going to be calling those instead of raising, then he's going to be folding a little less than that. So even here, like in reality, if the pool was somehow playing this type of c-betting range, they're probably still making a mistake and folding too much because they're not check raising their Queen X as aggressively. But another point is, if they did construct their betting range like that, let's take a look at what happens in a typical check fold the turn line. Like, does the fact that their flop c-betting range was reasonably strong mean that the turn check fold hotspot is invalidated? So we got 45%, and the pool's folding 57% on average, 60% on Queen High Rainbow. You notice how consistent the check fold on the turn is remaining despite the deviation on the flop c-betting range, and that's because PO's had the chance to reorganize and play an optimal range on the turn c-bet. But like I've said, there's just too many moving parts for me to go and estimate, to go and node lock everything and retain any sort of sensibleness. Let's just go back and take a look at what that c-betting flop that arrived at us with a check fold frequency that was matching what the pool was doing. I mean, it's extremely value heavy and very light on bluffs, and I'd say it's extremely unlikely that this is the type of range that the pool is implementing. And even if they do construct their c-betting range in this way, we've seen that the check fold hotspot wasn't invalidated. the check fold number the PO allowed was only approaching what the pool was doing, and that was with a significant check raise percentage. In addition, the check fold percentage on the turn after betting the flop was one that didn't invalidate the turn hotspot. So we've seen that from this that first we input a sort of simple version of a sort of estimated human range, and we saw that the PO allowable folding frequency was slightly lower than arose after the optimal C betting range. That only exaggerated the hotspot. Then we put in a mildly polarized range and saw the same effect. Then we put in an extremely polarized range and saw that widened the hotspot too. And then we put in an extreme sort of merged range. Narrowed the hotspot slightly, but it was still significant. I think the full percentage here was up to 35%. And then by adding in like lots of value to that merged range and merging it further with all the ace-x and keeping out all the bluffs, we found a range that would allow the small blind to check fold the flop with the sort of frequencies that the pool are doing. But even then they had check raise some hands that we know just aren't getting check raised, like Queen 9 through Queen 8 on the Queen High board. So I think this shows that the methodology can be applied. We input several ranges there, several different type of range constructions, and we saw that the hotspot wasn't invalidated. The only time it was invalidated was when we put in, a sort of reasonably ludicrous range with no bluffs in it at all, such that the check-in range was particularly weak. Let's just take a look at the exploit against that range. On the check, what imposition can do. Can stab like almost all the time. So having played around, we've found a range that seems like it allows them to check fold with the sort of frequency they're check folding at. It's clearly far from optimal, but even then we can see that imposition's not doing anything wrong by firing aggressively. So I think we can conclude that whilst the range construction does affect the PO suggested fold frequencies, we have to go to pretty extreme lengths in terms of range construction deviations in order to find anything that even matches what the pool's doing.